you an insight of 5 minutes. After that, we are going to see the questions only. Clear? So, if I discuss about the consolidation of soil, we know that when there is a superstructure load, due to that particular stress value, there will be expulsion of pore water. There will be expulsion of pore water from the voids of the soil. Yeah, hi Assis, from the voids of the soil. Due to that particular stress value or due to this expulsion of pore water, there will be change in volume, right? Or there will be decrease in volume of soil. This particular change in volume or decrease in volume, we call it as a consolidation, right? So generally we have two types of consolidation, that is primary consolidation and secondary consolidation. Your primary consolidation, it is mainly due to the expulsion of pore water. Clear? There is also one secondary consolidation. Mainly you will find it in the clay soil or plastic soil. That is your mainly due to the readjustment of soil particles, right? Or plastic readjustment of the particles. Clear? But mainly if we talk about the Terzaghi theory is the most important theory in this particular course, right? So if we talk about the Terzaghi's theory, right? Or Terzaghi has given one spring analogy method just to understand this particular process, and according to him, this consolidation process, you can represent it with a differential equation, that is del u by del t, it will be is equal to Cv into del square u by del z square, right? So change in the pore water pressure with time, it can also be understood with the help of this consolidation process. You can understand that process with the help of that how your pore water pressure is changing with time. Clear? As when you'll apply the load, first that particular load, it will be taken by whom? It will be taken by water. Now with the time when this water will get path to expel from the soil, due to this particular expulsion of pore water, your excess pore water pressure is going to reduce, and that pressure now it will be transferred to the solids. Due to that particular, your solids is going to get compacted, right? And your voids are going to get reduced. Clear? And this particular reduction in voids, reduction in volume, you call it as a compressibility, or here, as it is due to the expulsion of pore water, you will call it as a consolidation. Clear? So this is the particular Terzaghi's equation, right? Now the solution of this Terzaghi's equation, if you talk about this particular equation solution, one of the solution is your degree of consolidation. That is your degree of consolidation, right? Mainly represented by U. What this degree of consolidation suggests? This degree of consolidation is, it is the how much proportion of total consolidation, how much proportion of the total consolidation it get completed at any particular instant of time, it will be given by this degree of consolidation, right? So degree of consolidation, we can say it is whatever is the consolidation at any particular time h, whatever is the particular consolidation at any particular time h divided by total consolidation, or sometimes you call it as a total settlement. Clear? If I represent it in percentage, you can multiply it with 100. In terms of void ratio also we can explain this, right? There will be reduction in the void ratio, like that also you can explain this, or you can also explain it with the reduction in the pore water pressure. Like initially, let's suppose Ui is your initial pore water pressure, right? At any particular time, now the pore water pressure reduces from initial value to this ut value. Clear? How much will be the total reduction? It will be from initial value to 0. When the pore water pressure, excess pore water pressure will become 0, it means at that particular point your consolidation process get completed, right? So like this also, sometimes you represent this degree of consolidation. Clear? Now we will talk about mainly the type of question which can be asked from this particular chapter. What mainly examiner asks you in this particular chapter? There are two type of question which can be asked. First is, if the settlement value is given to you at any particular time, if settlement value is given to you, it will ask you that how much time it will be required for this particular settlement value. Clear? Like it will ask you that, okay, there is a 25 mm of settlement. It will give you the properties of soil. It will give you that okay, there is a 25 mm of settlement, and it will ask that how much time it will require. How much time it will require for this particular settlement value. This is one type of question. Second type of question is, it will give you the time. Let's suppose it has given you the time as 3 years. It has given you the time as 3 years, and it will ask you that in these 3 years, how much settlement will be there? How much settlement will be there? Clear? So these are the two type of questions which are generally asked in your exam. How to process this type of questions? Now try to see. If delta H is given to me, right? I'm assuming that total settlement is also known to me. I can find out what is my degree of consolidation. I can find out what is my degree of consolidation, that is delta H upon capital delta H into 100 if I am taking it in percentage. Right, now this degree of consolidation, it is related with the time factor, right? So time factor is the quantity which relate degree of consolidation or which relate this settlement value with time, right? Now your TV is equal to pi by 4 of U square. Clear? What is this U? U is your degree of consolidation. Here this U is in decimals. Right? Remember that here the U is in decimal, right? This particular formula, it is valid when your U is less than 60%. When your U is less than 60%. If your U is greater than 60%, your TV value will be 1.78 minus 0.9332 log base 10 100 minus U. Here you have to use the U in percentage. This U is now in percentage. Clear? So remember this particular formula also. Right? Now, once U is known to you, you can find out the TV value. Once TV value is known to you, now this TV also connect you with this particular time. Now, TV, we have another formula that TV is equal to CV into T by D square. CV into T by D square. From here you can find out this particular T value. Clear? What is this CV value here? What is this D value here? Here CV, it is your coefficient of consolidation. Coefficient of consolidation. Right? What is this D? D is your length of drainage path. D is your length of drainage path. Clear? Sir, what is this length of drainage path? It is the particular distance, or it is the maximum distance which a water molecule has to travel before expelling out from the clay layer. Why I am saying clay layer? As we generally focus about the consolidation of your clay layer only, right, or clay soil only. As when there is a construction, that particular coarse grained soil, that is your sand, it is having a greater permeability, right? Your permeability of coarse grained soil is more, that is in sand. So whatever is the consolidation, whatever will be the consolidation in your coarse grained soil, it will be done during the construction period of your building only. Now for us, what is more important? Let's suppose we have constructed one building, right? Today we have constructed one building, and after 3 or 4 years, if my soil below our foundation, it is going to get settled, that is the mainly problem for us, right? For a civil engineer, that is mainly the problem. We know that the settlement of sand, it will be completed within construction period only. It means the problematic soil for us from the consolidation point of view is clay. So that's why we mainly take into account the consolidation of clay only, right? Now, this is the particular process. If settlement is given to you, how to find out what will be the time required? If time is given to you, this particular process you can repeat in this particular cycle, right? So remember this particular cycle. You can also take the screenshot if you want.